Okay, here is Unit 1, second day. This is on function graphs. Besides looking at graphs of functions and answering many questions about them, we're first going to start with identifying the domain of functions from an equation. Before we were doing it from ordered pairs and arrow map. Here's from an equation. Okay, so let's refresh our memory. The domain of a function is all the input, the x values that could be put in for this function. So here we have three different types of equations. Number one is a quadratic equation, is x squared. Number two is a square root, a radical equation. And then number three is something called a rational function, which we're going to be getting into in the next unit, or basically a fraction. These are the only three that I'm going to be giving you. So first question is for number one. What kind of numbers can I replace in here for x? Does it matter? Can I have decimals? Can I have fractions? Can I have negative integers and positive integers? Yes, I can have basically anything that I want to be put in here in this polynomial, in this quadratic equation. So the domain, you would write, is all real numbers. And they write a fancy capital R like that to represent all real numbers. So you could write it like this, or you could basically just write it out, all real numbers. Whichever one you prefer. All right, number two is a square root of radical. Well, what kind of numbers are you allowed to have underneath a radical? Can you have a 0? Yes. Can I have 1, 2, 3, 4? Can I have a half? Can I have 4/5? Yes. The only type of number I can't have under the radical is a negative integer, because that's not allowed, a negative number under a square root. So we are going to set up an equation, taking out what's underneath the square root. This is what you always do. And I want to know anything that's greater than 0, or it could equal 0. That would be the possible values that I could plug in for this square root that would satisfy the domain. So if you have a square root equation, you're always taking out what's underneath, setting up an equation exactly like this, greater than or equal to 0, and then I'd like you to solve it. So to solve this for x, I'm going to subtract 4 on both sides. Bring down the inequality symbol, greater than or equal to, and 0 minus 4 is negative 4. So my domain here is all x's that are greater than or equal to negative 4 will satisfy number 2. All right, number 3 is a rational function, a fraction. Can I have negatives in a fraction? Yes. Can I have a fraction inside a fraction? Yes. Can I have a 0 in a fraction? Yes, but where can you never, ever have a 0? Where is it never allowed in a fraction? It's not allowed in the denominator. So I could have everything I want in here for x, except I have to figure out what makes this bottom part of the fraction equal to 0. So I'm going to take out my denominator and solve this for x. So when I solve it for x, I subtract 1, I divide by the negative 3. Those two negatives become positive. Now, what does this tell us about this answer? How would I write this answer? So I could have anything I want for my domain. So I could have any real number, except, so the except is this slash that I'm putting here, except I can't have 1/3. Because 1/3 will make the bottom 0, and that's not allowed in math. All right, here are another 3, just like the one that we did. I'd like you to go ahead and, write these down, pause it, see if you can figure out the domain for each of these, and come back. All right, so for number 1 here, it is a fraction again, except we have this huge polynomial in the denominator. And remember, we cannot have a 0 in the denominator. So I took that whole bottom out and made it equal to 0. All right, now here goes back to algebra. Do remember what to do when we have a polynomial equal to 0. We need to do our fancy word of factor. Who remembers how to factor this polynomial? So I'm going to factor this trinomial, finding out what are the factors of negative 4 that add up to negative 3. So negative 4 times 1 add up to -3 and multiply to -4. So I'm setting up my equation like this. Hopefully everybody remembers. I'm going to split it apart so that each factor equals 0. Solve each of those for x. So my domain for number 1 is I can have all real numbers except 4 and -1. All right, for number 2, here's that square root radical like the other problem before. Again, we cannot have a negative number underneath the radical, the square root. So I'm taking what's underneath, I'm taking that out, 2x plus 3, writing the inequality greater than or equal to 0, and solving it for x. Subtract 3, divide by 2. So my domain for number 2 is all x's can have to be greater than or equal to -3/2. And for the last one, number 3 is an easy one. That's our polynomial, our quadratic. I could have anything I like there, so it's all real numbers. All right, for the last part of this lesson is looking at a graph that I give you with lots of points on them and answering questions like this on the left-hand side here. So we're going to go through these as best as we can. Then there's another example that you're going to try yourself and see if you can get the answers. All right, so how do I find f of numbers from a graph? So number 1's asking us to find f of 0. So that means I'm going to my x-axis, which is here. Here is 0. Well, what is f of 0? I'm going to go ahead and take a look along the y-axis, and f of 0, what is the output there? It is 3. I'm going to do the same thing for f of -6. Go to the x-axis, where -6 is, which is here. Where do I see the graph? For the answer, it's down below. What's the output for f of -6? -3. All right, for number 2, f of 6, I go to 6 on the x-axis again. What's the output there? 0. I go to f of 11, 11 on the x-axis, looking at where the graph is. Here it is. The output is 1. Okay, is f of 3 positive or negative? Meaning, is the output of f of 3 a positive or a negative number? So I go to 3 on the x-axis again. Here it is. I go up. It's in the positive numbers for the output for y, so I put positive. How about f of -4? I'm going to -4 right here on the x-axis. They are down below with the negative numbers, so that answer is negative. Okay, for 5, what number is x? So meaning, what are my x values? Where f of x equals 0, so that means where is my y 0? So I'm looking where the graph crosses the axis, where it's 0 for the y. So here's one, here's another one, and here's the third one. So I'm listing the x values, which is -3, 6, and 10. Okay, 6, I'm looking for the numbers x again. This time I'm looking for where are they greater than 0? Above the x-axis, greater than 0. Well, I have a lot of things that are greater than 0 here. Here's the 0. I have this part of the graph that's greater than 0, and I also have this little piece here. All right, this answer here is going to be written in a range of values because it has so many answers. I'm going to be using brackets and parentheses to show where it starts and where it ends, this graph, where the y's are greater than 0. So let's take a look. It is starting right here at -3, but they want to know where it's greater than 0. So that's where it equals 0. So I need to have a parentheses around this -3 to show that it's starting at -3, but it does not include -3. Then the numbers keep going. All of these are part of it. All of these are part of it that are greater than 0. And then it comes all the way down over here to 6. 6 is at actually 0, but the numbers before it are part of greater than 0. So I'm going to write -3, comma, 6. And again, I don't want to include the 6, so I have a parentheses. Now we're starting with this little piece over here. It's starting at 10. So I'm going to have a parentheses for the 10 because I don't want to include the 10 because that's actually equal to 0. And it goes to where? Just 11. Now, is 11 part of this greater than 0? Yes, because the output is 1. So that means I want to include the 11. So I'm going to have a bracket around the 11. Okay, so parentheses I put over here on the right hand side doesn't include the number, while the bracket does include the number. All right, so let's take a look at 7 and 8. What's the domain and range of this function? Since they don't have arrows at the end, where does the domain start? What's the lowest value, the lowest x value? It's at -6. So I'm writing bracket -6 because it starts at -6 with a solid dot and goes all the way over to 11 with a bracket around the 11. What's the range? That's my y values. So the lowest y value is down here at -3. It includes it. And what's the highest y value? Goes all the way up. Looks like it's at 4 and includes that because it's solid. Okay, I'm looking for the local maxima and minima point. Maxima means the highest point on the graph. Minima means the lowest point on the graph. So the maxima point is 2, 4. And the minima point is -6, -3. All right, now we're looking for the interval with those brackets, parentheses, about where the graph is increasing and decreasing. Increasing and decreasing on graph always go from the left-hand side to the right-hand side. So where is it increasing? When it's getting bigger. So if I take a look here, it's starting at -6 and it's increasing all the way up to +2. It's increasing from -6 to 2, and it's also increasing from +8 to 11. Okay, where is it decreasing? Here's the part where it's going down. It's going down from +2, to +8. So for these intervals for increasing and decreasing, you're always using your x-axis values. All right, number 11. What values of x does f of x equal 3? So again, f of x is my output, my y value. Where is y equal to 3 on this graph? All right, I see 2 spots where the x is 0 and where the x is 4. 0, 3, 4, 3. Okay, take a look at 12. Where does the x values, does f of x equal -2? So I'm looking, where is -2 the output, the y? I see one here and I see one here. So my x values are -5 and 8. Okay, so here's the second graph on that PDF document. I suggest that you pause the video, don't look at these answers, try it yourself. And again, if you have any other kind of questions on these answers, definitely in office hours, we could talk about it.